What if I told you that predicting tomorrow's stock prices, optimizing marketing campaigns, or even understanding how pandemics spread all boils down to one simple idea? A straight line? Yes. Welcome to the world of linear regression. In the next couple of minutes, I will make linear regression so simple that by the end, not only will you understand it, you will be able to code it from scratch. Ready? Let's dive in. Linear regression is one of the simplest and most widely used algorithms in machine learning. At its core, it's about finding relationships, discovering how one variable changes with another. It answers questions like, if we increase our marketing budget, how much will our sales grow? How does temperature affect electricity consumption? It is easy to understand. It's interpretable. You can explain the results to anyone, even without a technical background. Linear regression operates under a simple principle, that is, y is equal to mx plus c, where y is the target variable we want to predict, x is the independent variable, that is our input, m is the slope, showing how much y changes when x changes, c is the intercept, indicating the baseline value of y when x is 0. Hey, if you are finding this helpful and want to explore more concepts like this, hit the subscribe button. It really motivates me to bring more content like this for you. Alright, we have understood the theory, but let's see it in action. First, we import three essential libraries. Pandas for data handling, scikit-learn for building our linear regression model, matplotlib for visualizing our data. Next, we load two datasets, train.csv for training the model and test.csv for evaluating its performance. These datasets simulate the real-world scenario of building a model with existing data and testing it on unseen data. To get a sense of the data, we take a quick peek using head method to view the first few rows. Then we check the shapes of both datasets to ensure they have the expected number of rows and columns. We inspect the data for missing values using isNA.sum. If we find any, we handle them to ensure our model isn't affected by incomplete data. Here we use drop-NA to remove rows with missing values. Clean data is the foundation of any good model. Using describe, we generate key statistics about the dataset like mean, standard deviation, and ranges. Now comes the fun part, plotting. We use scatterplot to visualize the relationship between x and y for both training and testing datasets. This helps us see the trend and validate whether a linear relationship exists. We extract x and y from both datasets. These are reshaped into the required format for our linear regression model. Here is the star of the show, the linear regression class from scikit-learn. We create a model instance and train it using fit method, passing it xtrain and ytrain. This step finds the best fit line by minimizing errors. Once trained, our model predicts y values for the test data using predict method. This is where theory meets practice. We test how well our line captures the trend in unseen data. Finally, we visualize the model's performance by plotting the predicted line against the actual dataset. If the line closely follows the points, it means our model is doing a great job. The red line represents the predictions, while the scatter points show actual values. We have mastered the basics with our first linear regression example. Now it's time to tackle a larger, more realistic dataset. Let's get started. We start by importing library keys, pandas for data handling, numpy for calculation, matplotlib or seaborn for visualizations. These tools will help us process, analyze, and model our data efficiently. We load the e-commerce dataset and take a quick look using head method. The dataset contains columns like average session length, time on app, and yearly amount spent. Using describe and info methods, we check for missing values and data types. Everything looks good. Time on app versus yearly amount spent. Does app usage impact spending? Length of membership versus yearly amount spent. Does loyalty matter? A pair plot and heat map shows us all relationships and highlight the strongest correlations. We drop irrelevant columns like email and avatar to focus on meaningful features. Next, we define X and Y. Features include average session length, time on app, and so on, while target is yearly amount spent. We split the data into training and testing sets, that is 70% is to 30%, and build a linear regression model using linear regression method. Using the test set, we make predictions and evaluate them with metrics like mean absolute error, mean square error, and root mean square error. These scores show how close the predictions are to actual values. A residual plot reveals how well the model fits. Ideally, the residuals should be randomly distributed, showing no patterns. And that's it. From understanding the basics of linear regression to applying it in real world projects, we have covered a lot today. But remember, this is just the beginning. Don't forget to like, share, and subscribe for more awesome content. See you in the next video.